Hello again. So last time we saw a prototype example of the DP problem, the shortest route problem of a network. In this lecture, I'd like to present the basic features that characterize dynamic programming problem. As we know that there does not exist a standard mathematical formulation of dynamic problem. Therefore, one way to recognize a situation that can be formulated as a dynamic programming problem is to notice that its basic structure is analogous to the network problem. These basic features that characterize dynamic programming problem are presented and discussed here. Now, I want to discuss the characteristic of dynamic programming problem one by one. The first characteristic is the problem can be divided into stages with a politicization required at each stage. We can see the network problem. We can split this decision into stage 1, stage 2, then stage 4, then go on. Then the policy decision at each stage with which route to choose. Characteristic 2. Each stage has a number of states associated with the beginning of that stage. The state, such like this, in the stage 1, it has one stage. It's as one state. We denote it by S1. Is A, and the second stage, the state is B1 and B2. The third, C1, C2, C3, C4, the 3 stages. The number of states may be either finite or infinite. Characteristic 3. The effect of politicization at each stage is to transform the current state to the state associated with the beginning of the next stage. For example, in the network problem, the decision in the stage 3 from this state is to decide which path I shall go. We'll choose to D1 or to D2. So the decision is to transform. If we choose this path, then the state C1 is transformed to D1. So the effect of politicization at each stage is to transform the current stage to a statistic associated with the beginning of the next stage. Therefore, the solution proceeding is designing to find an optimal policy for the overall problem. That is a prescription of the optimal policy for each the possible states. For example, in the prototype example we illustrated last lecture is here. We draw that the optimal decision for the first stage is C1 to D1, and the second the state for the state C2 is C2 to D2, and for the state C3 is to D2. So we need to find an optimal policy for the overall state of each stage. Then to the fourth. Given the current state, an optimal policy for the remaining stage is independent of the policy decision adopted in previous stage. There, the optimal immediate decision depends on only the current state and not on how you go there, which means that the state of the next stage is only transformed from the last stage and the decision. So we can see that the optimal policy for the remaining stage is independent of the policy decision adopted in the previous stage. There, the optimal intermediate decision depends on only the current state and not on your got there, and not on how you go in this state. This is the principle of optimal for the dynamic programming. It's a very important priority for dynamic programming. Then, characteristic 6. A recursive relationship that identifies the optimal policy for stage n given the optimal policy for stage n plus 1 is available by this formulation, which are the optimal solution, optimal policy for stage n plus 1 plus the immediate policy from Sn to Xn to the next stage, to the every possible state of the next stage. Xn means the every possible state of stage n plus 1. This equation is the last is the optimal decision, optimal value of the last stage. We call it boundary. The 7. The solution procedure begins by finding the optimal policy for the last stage. We can see from this formulation, we must determine or give the boundary condition. Then use this recurve. We can find the stage n from n plus 1. That is the solution procedure, beginning by finding the optimal policy for the last stage. When we use the recursive equation, solutions procedure starts at the end and moves backwards. It's a backwards by stage. Each time finding the optimal policy for the stage until it finds the optimal policies starting at the initial stage. Here, the optimal in the formulation is the abbreviation of optimal. Max or minimal can be taken according to the meaning of the question. Thus, the recursive equation will always be of the form like this: minimize or maximize. It's the optimal, that means optimal. So here, optimal has two cases: minimize or maximize. Okay, that's all the characteristic of the dynamic programming. There does not exist standard mathematical formulation for the dynamic programming. Therefore, one way to recognizing a situation that can be formulated as a dynamic programming problem is to notice that its basic structure is analog to the network problem. We have presented 8 characteristics of dynamic programming problem. These basic features that characterize dynamic programming problem. Next time, I will use example to show you this characteristic and how to solve a dynamic programming problem. That's all. Thank you.